which is time value of money by using Foundation of Financial Management 18 editions. This is book by publisher by Block, Hurt and Dennison. Okay. This is owned by McGraw-Hill in terms of copyright. There are quite a number of learning objectives. Let's start with this one. Okay. I'm gonna move this slide is over here so it's easy to use. All right. Let's start here. There are only objectives, so a number of them, but 5 of them. Explain the time value of money and how a dollar received today is worth more than a dollar received in the future. Recognize the future value is based on the number of periods which the funds are to be compounded at a given interest rate. Recognize the present value is based on the current value of funds to be received. Calculate the yield on investment, rate of return, annuity due and payment required. Recall the compounding or discounting that may take place on a less than annual basis for such as semi-annually or monthly. And then time value of money in terms of relationship to decisions, capital outlay decisions that we start. Time value of money used to determine whether future benefits sufficiently large to justify current outlays. Mathematical tools of time value of money used in making capital allocation decisions. There's a future value of single amount. Measuring the amount allowed to grow at a given interest rate over a period of time. An investor, example, have $1,000, need to calculate its worth for 4 years or 10 years interest. So how are you going to calculate? First year is like this, 1100. Second year is 11 times 1.1 or 1210. And then 1210 here at the beginning of third year times 1.1 we got 1331. Fourth year we can 131 times 1.1 we got 1464.10. Okay. This is the formula, future value equal to present value, and close bracket, 1 plus I divided by N, where FV will be future value, PV will be present value, I will be interest rate, N is the number of periods. In the previous case, 1000 I equal to 10% equal to N4, so we're going to use 1000, 1.04 equal to 1000 times 1.464 equal to 1464.10, that's it is. Okay. This is how you're going to period using the formula. If you're using a table, this is what I used during when 30 years ago. This is when we do not have a financial calculator. We use the fourth year, 10%, we use 1.464. That's why you get this number coming from this one. Yeah. Okay. So the easiest way to use calculator. Present value single amount. Sum payable in the future is worth less today than the stated amount. The formula for the present value is derived from the digit formula. This is your formula. This is your base. And when you reverse it, it's going to be like this. Present value equals future value. 1 divided by 1 plus I divided exponential n. Okay? So present value, which is determined by the formula, which is present value in terms factors. Assuming n equal to 4, I is equal to 10%. Present value at 1464 divided by 0.683 equal to 1000. Where you get the 0.683? So based on the present value test factors, you get a 4 here, 0.6783 is coming from. This one showing up here, okay? That's how it goes in terms of present value interest formula. Now 9.1, the relationship of present value to future value. 1464 is the future value of present value interest. The X line represents the number of periods. The X line which represents the present value. Interest rate or single amount measured to return if investment determine unknown variable. I given the following variable, future value divided by present value, which is the present value of money, and it's a number of years. I equal to future value divided by present value, exponential 1 divided by n minus 1. Okay, that is for the interest rate single amount. For the interest rate, then we're going to go in for the number of single amount. Determine how many years it will take for investment to grow to a certain dollar amount, find the number of periods, and given the following, this is the formula. So we're going to look the same formula. We're going to look for the n. N equal to linear divided by future value divided by present value, close bracket divided by linear, close bracket 1 plus I. Okay, this is how you do it in single amount. For the future value annuity, what is annuity? Annuity is a series of consecutive payment of receipt or equal amount. Excuse me. Just grab water. It's an ordinary annuity payment assumed at the end of each period. Future value of an annuity. Calculate by compounding each individual payment into future and then adding up all these payments. So first period, 1231. Second period is 1210. Third period is 1100. 4 plus 1000, we get 4641. This is the of annuity. So how are you going to do that? If you look at this annuity, fourth period, 4.64, that's how you get it from the table. Okay? Then we continue. This is the formula. Future value equal to annuity equal to A times future value interest factor annuity. FF4, which is future value of annuity. Future value interest factor, which is annuity factor. This is the formula. A is represent annuity payment, I is interest rate, and this is the number of payment. Assuming A is 1000 and is 4 and I is 10%, you just plugging in, you get this 464. Again, going back to the here 464. Okay, that's how you get. This is for the annuity every year. Okay. Then we continue for the next one. Why is that showing up? That's it. This is the one. Slide. Okay, we can move it. Next. How come it doesn't show up? Doesn't allow me to show up. Okay, look at this one. Slide. Okay. Surprisingly, it doesn't show up. Doesn't allow me to do so. All right, so let's do that. Calculate the discount each value for a period. Okay. This is the present value annuity. Calculate discount each the equivalent fact. Present value, generalized for present value annuity. Present value equal to A divided by annuity times present value interest factor. Where is it? Present value A equal to present value annuity. Present value interest factor, which is the annuity factor. This is the formula here because it's annuity, right? A is annuity value, I is interest rate, N is the number of periods. Okay, it doesn't see it goes up. Okay, let's do it one by one there. There's no problem. So we're gonna go from the current slide. Okay, so this is where you got 3.170. Okay, when you go back here, you got the 3.70. Let's continue. Okay, I'm gonna share the circuit. I don't know, there's a technical glitch, guys. So we're gonna continue here. The relationship between the future value and future value, present value, future value and present value of a single amount. Where image is value, for example, in 9.3, the future value is 0.68 at 10%, and we figured 9.4, the present value is $1 at 10%. Okay, this is a given example at 0.68% at 10%. Okay, for period 1 is 0.683 all the way, future value. Okay, and for the present value will be the reverse period there. Okay, and then the relationship between present value of single amount and present value annuity. The present value annuity is the sum of present value in a single amount payable at the each period. The assumption is $1 received at the end of each period. The same concept as the lottery winning. Okay, so how are you going to look at this in the future? So this is the future present value there. You look at here, period 1, period 2, period 3, period 4. This is example, period 1 is 9.9, period 4, period 2 periods, third period, and fourth period. Fourth period, you're going to reach this every year 1, year 2, year 3, and year 4. So this is present value annuity for the fourth year. Okay? Now, let's look at the future value related to the future of annuity. Okay? The future value of annuity is the sum of the future value of a single amount receivable at the end of the period. The future value $1, assume that $1 invested at the beginning of the period grows to the end of the period. The future value of annuity, assume $1 is invested at the end of the period and grows to the end of the period. So the next future value is $1 times 10%. So you get, this is the logic here. For period, you get, this is the future value, you get 1.33, okay, 1.21, 1.1 for future value in period 4. Okay, that's where the logic is. Then you get this number. Okay. Remember here, this is the beginning period, this $1. $1 here, $1.10, $1.10, and 121, 121, and 133. You add it up. Okay. Determine the annuity value. Reviews the variable involves the time value of money, future value, present value, and it's the number of years, I interest yield, is annuity payment for period annuity, given the first three variables, and then the fourth variable, which is the A, the unknown. Okay. Annuity equivalent for future value, example, assuming a 10% interest rate after 4 years, amount is 4641, needs to be accumulated. You're going to calculate future value annuity equal to annuity times future value interest factor annuity, where the A is going to be future value annuity divided by future value interest factor annuity, assuming N is equal to 4 and I is equal to 10%. You're going to plug in the number A for 641, 4641, you get 1,000. That's how you get this logic. Okay. Moving on, determining the lot size of the annuity can be given, or the amount is present value A equal to A annuity times present value interest factor. Annuity, what is the annuity? Will be present value annuity divided by present value interest factor annuity, assuming the N is equal to 4 and I 6%. So A equal 10,000 divided by 3.465, then the A will be 2886. That's how you get that number. Okay. Level 9.1 shows you the relationship of present value annuity based on the beginning of each year balance. 1,000 beginning at 1,000 here. Interest is 600. Withdrawal is 2881. Ending balance is 71. So you're going to go back here, year 2. 7741. Interest is 6%. Withdrawal to 881. You got ending balance here. 5291. Year 3 is 5291 here. Interest is 317.63. And then withdrawal here to 885.91. The remaining is 2722.58. So this is how you're going to calculate that number. Okay. You do the table in sequence. Annuity equaling for present value continue here. Some process used to indicate as a loan repayment. For example, here, mortgage loan is 80,000 to be repaid over 20 years at 8%. Interest, so what's the annuity? You're going to plug in the number based on the formula. You got the 8148.18. Okay. So part of the payment will be, you're going to pay here. Beginning 8,000, payment, annual payment 8148. Interest 6,400, principal payment will be 1,748, ending balance will be this one. So you're going to get the ending balance year 1, going to go back to become the beginning balance of year 2. You're going to do an annual payment here, 8148, annual interest 6260, repayment principal 1888, ending balance is 76364. And then the beginning of the ending balance of period 2 become the beginning period of the balance of period 3. You're going to do annual payment again, the same kind of number. The annual interest will be 6109. Repayment on principal will be 2039. Then you got the ending balance 74325. Okay, the compounding frequency over the additional period. Compounding frequency is a certain contractual agreement may require semi-annual, quarterly, or monthly compounding periods. In such cases, adjust to the normal formula, n equal number of years times number of compounding periods during the year. I quoted the interest rate, number of compounding periods during the year. Okay. Case 1, when you do compound semi-annually, find the future value of 1,000 investment after 5 years at 8% annual interest, where n equal to 5 times 2 equal to 10. I is 8% divided by 2 equal to 4%. Remember, this is with semi-annually. So because semi-annually, you got to divide everything by 2. 10 and 5 years times 2 become 10. For the n, I become 4%. And you're going to use the formula. And you're going to plug in, you got 14840.24. Okay? And then case 2, compounded semi-annually. Find the present value of 20, quarterly payment of 2,000 each to be received over the next 5 years at 8% annual interest. Then you get this number. A equal to 2,000, N equal to 20, I equal to 8% divided by 2, equal to 4%. You plug in the number. This is the formula here. You're going to plug in the number. And then you got this logic, 32,702.87. You just plug in the numbers, okay, based on the formula given to you. In terms of the pattern payment, for deferred annuity, pattern payments mean problem may evolve around numbers of different payment or receipt patterns. Not every situation involves single amount or annuity. Contract may call for payment of different amount each year of a stated period or period of annuity. So where the logic is coming from? Assume, for example, involve payment of a different amount each year for 3-year period to determine the present value each payment, discount the present value total, assuming 8%. So example, this is present value interest factors given to you by the table. 1,000, you become times 0.926, become 9,226 present value. Year 2, 2,000 times 0.857 become 1,714. Payment 3,000 times 0.794 become 2,382, become 5,022. Okay. More complicated problem is when the situation includes combination of single amount and annuity. When annuity is paid at some time in the future, it is referred to as deferred annuity. It requires special treatment. Assuming a contract involving payment of different amount each year for 3-year period, annuity is 1,000 paid at the end of each year from 4th to 8th year, then 8% discount rate. So this is 1,000 all the way to 8 year. Present value is 5022, 5-year annuity. To know the present value first 3 months, 5022 from previous calculation, diagram to the annuity payments, and it begin at the end of the year 4. So 1,000 here, 1,000 here, all the way up to the year 8. Okay? And then you do a present value annuity. At the end of the third period, we get the fourth period, which is here, present value interest factor annuity, 3993. Each number represents the end of it, that is 4 represent the end of the fourth period. So to discount 393 back to present, which fall the beginning of the fourth period, discount back the 3 periods at the 8% of interest rate. So how are you going to calculate that? This is the formula, 3993, 1.1.0833, present value will be 3170. That's the first one. You discount it back for this number, okay? 8%. Then second period, present value 5-year annuity, maybe now we added 5022. Present value for 3 period flows plus 3170. Present value of the 5-year annuity become 8192 total present value. Because remember this logic, okay? 1, 2, 3, 4, 5. Okay, you got this is present value 1022 totaling up. So when you look at the logic here, formula, you're going to calculate this formula, okay? This is all of the formula being used. Remember this formula, this is your base. Okay, this is your base, this is your substitution, this is your table formula. Then 192, just reverse the osmosis. This is future value interest factor, this is present value interest factors. So that's basically conclude this chapter. I will upload this in YouTube as well as for a puzzle for your interactive learning. Thank you, everyone.